The next topic is the Heisenberg picture. In the Heisenberg picture, it should be noted that the operators must be dependent on time t, and the wave function remains constant in time. The wave function remains constant in time. So this is the reverse process in the Heisenberg picture. The operator must be dependent on time and the wave function remains constant in time. And generally, this expression for any operator A, dA divided by dt, can be written as iota divided by h cut, the Hamiltonian of the system and A. So this is dA divided by dt. This is the mathematical expression. Now, to derive the above relation, we take the expectation value of an operator as. Let's see, if we have to derive this expression, then let's take the expectation value of A, any operator. This is a general operator A, and psi of t, A, and psi of t. And we know about the psi of t from the Schrodinger picture, that this psi of t, which is equal to e to the power minus iota h t divided by h cut and psi of 0. We know about this. Putting these values, so A, which is equal to, then this term must have the form like psi of 0 and e to the power iota h t divided by h cut and A, and this is minus ht divided by h cut and psi of 0. This term as the Heisenberg is known as the Heisenberg operator. Then this A of t will be equal to psi of 0 and A of t and psi of 0. So the expectation value we can write in terms of this as. So in this case, you can see the operator, this operator A is dependent on time. This is dependent on time, but the wave function is independent of time. Now the question is why we call this as a Heisenberg picture. And to know about this, we consider an operator which is equal to e to the power iota h t divided by h cut A of 0 and e to the power minus iota t divided by h cut. This is the operator, the Heisenberg operator, and differentiate this with respect to t. If we differentiate this with respect to t, then we must take the product rule, and according to the product rule, e to the power, first differentiate this iota h divided by h cut and e to the power iota h t divided by h cut and a 0 and e to the power minus iota h t divided by h cut. Then plus differentiate this and take this common, e to the power iota h t divided by this and a of 0 and minus iota h divided by h cut and e to the power minus iota h t divided by h cut. So this is the differentiation. And further, uh, if I take IH divided by h cut, this term, then this term as nothing but this is known as A of t, and we have a minus because this is first this and this, so we can take this A of t, and the remaining thing is iota h divided by h cut. Here we have a common, iota divided by h cut is common, and here this is h, this is A of t minus A of t and h, and this is nothing but this is the commutation relation between A and t. So this dA divided by dt, this is equal to h, and this is known as Heisenberg uncertainty principle, because if this the value if this and this, the commutation of these two operators is equal to 0, then there is no uncertainty, and if this is not equal to 0, then there is some uncertainty between this. So this is why we call this Heisenberg picture. So this is based on Heisenberg uncertainty principle.